Welcome everyone to West Explains Best. Today we're doing another Khan Academy tutorial, and this is Mr. West. Our first Khan Academy that we're doing today is parallel and perpendicular lines from equation. Let's go ahead and jump right into it. What do the following two equations represent? So it gives us two equations, and we're supposed to choose from the multiple choice. These are all the options that two equations, the relationship that two equations can have. They can either be the same line, meaning they have the same slope and the same y-intercept. They can be distinct parallel lines, which means they have the same slope. They can be perpendicular lines, which means they have opposite reciprocal slopes. And the y-intercept is not important there. For B and C, the y-intercept is really not relevant. And then they can be intersecting but not perpendicular lines, which means they just have different slopes. Different slopes for different folks. Okay, now how do we determine this? Well, we need to be able to identify our slope in both equations. In the top equation here, you'll see that it is in point slope form. So if you're not familiar with point slope form, you might want to watch one of my videos on that. One of the notes sections or one of the CUDA tutorials or Khan Academy tutorials. But point slope form is very useful. It's actually my favorite form for dealing with solving equations algebraically. But with point slope form, let me just get kind of into the crux of it. Anytime the format is you're going to have a y plus something on the left, the x plus something on the right, and then your slope is going to be multiplied by the parentheses where x is. Okay, so that is always going to be your slope for point slope form. So in this case, our slope is -4. Okay, the second one, and if you want to hear more on point slope form, again, try to check out some of the videos. This is in standard form. Okay, I also have more videos on standard form if you want to learn how to graph it. But if we want to find the slope, it's not so simple. What we have to do is we have to solve for y and get it into slope-intercept form. So we have basically the three forms here. We have point slope, standard form, and we have slope-intercept form. Slope-intercept form is y equals mx plus b. So I kind of got it started over here on purpose. So we have y equals your slope times x. I'm going to put this in parentheses, and then plus your y-intercept. So that's what we're looking to get standard form into. We're hoping to get it into that, so we have to solve for y. Let me go ahead and do that. Let me go ahead and do that over here. So the first thing I'm going to do is I'm going to subtract 2x from both sides. So I have negative, so I would subtract 2x, subtract 2x. So we have negative 8y equals 16 minus 2x. Now I'm going to divide by -8 to both sides. Keep in mind, I need to divide both terms on the right by -8. So I get y, it's by itself now, equals 16 divided by -8 gives me -2. And then we have -2x divided by -8. That gives me a positive 1/4x. Now, the y-intercept is not important. For essentially all of these, the only one that's important is with the same line, it needs to have the same slope and the same y-intercept. Okay, so the only time the y-intercept is relevant is if we're looking to see if it's the same line. In this case, it doesn't have, like, we don't care because we see that we have different slopes. The first one was -4. This one is 1/4. So how are they related? Well, -4, if we want to put it in fraction form to compare it to see if it's reciprocal slopes, we just put it over 1. Any integer we can put over 1 and not change the value. So now we want to see how it compares with 1/4. Okay. Again, we had to check if it's opposite reciprocal slopes. So how do we check to see if it's opposite reciprocal? So we have a box for opposite, we have a box for reciprocal. Are they opposites? Is one positive and one is negative? Yes. This one's negative, this one is positive. So they're opposites. Bingo. What about reciprocal? Are they flipped fraction-wise? So 4/1 and then 1/4? Yes, they are opposite reciprocal slopes. That means these are perpendicular lines. All right, next one. 3 more, it says. What do the following two equations represent? Both of these are in standard form, so now we have to solve both into slope-intercept form. Y equals mx plus b. We need to solve for y. The first one's pretty easy because y is already by itself and positive, so we just need to subtract 5x from both sides. And we get y equals negative 5x plus trace. Our slope is going to be negative 5. It's the number in front of x. Now, the bottom one, again, not too bad, but again, we have to solve, so we're going to subtract 10x from both sides. Try to get the y by itself, so we have 2y equals negative 10x. See, I put the negative 10x first. You can do the negative 6 first. It doesn't really matter. It's commutative. You can just switch it around. As long as you keep the signs in front of the terms the same, or how they should be. Now I'm going to divide both sides by 2. Divide by 2, divide by 2. And essentially, I'm dividing the right side by 2, but because there's 2 terms, I need to divide each term by 2. That's what I'm showing here. And you get y equals negative 10 divided by 2, negative 5x. And it doesn't even matter what my y-intercept is. In this case, it's minus 3, but we don't really care. Actually, it is kind of important because we want to make sure it's not the same line. Because it's I'm going to take back that statement. So we have negative 5 and negative 5. So if it has the same slope, it's either going to be the same line or it's going to be parallel lines. But because the y-intercepts are different, let me just double check to see if we did that correctly. Yes, we did. Okay, so the y-intercepts are different. This one's negative 3, this one's positive 3. They are distinct parallel lines. So it's not this one, it's going to be this one, distinct parallel lines. All right, next question. Okay, standard form again. So we have to subtract x from this first one, subtract x. Whoops, I missed. I'm supposed to put it over to the right. I changed to blue, you know, why not? 3y equals negative x plus 5. Again, I could put 5 minus x, but this is the same thing. Now I need to divide by 3. Divide by 3, I get y equals, I need to put negative 1 over 3 x and then plus 5/3. I can just leave it as a fraction. Again, I'm just comparing, so I just need to see if it's the same thing. Now, let me just change this one to, let's go change this one to pink. Subtract 4x, subtract 4x. So you get 12y equals negative 4x plus 20. I divide by 12, so I divide by 12 to both the terms on the right. I get y by itself. Negative 4x divided by 12 is going to give me negative 1/3 x, and then 20 over 12 plus 20 over 12, okay? They have a common term. That term is 4, so I'm going to divide both the top and bottom by 4. Y equals negative 1 over 3 x plus, divide the 20 by 4, I get 5, divided by 12 by 4, and I get 3. What do you know? Okay, so this time, again, the y-intercept was important. Why? Because they're the same y-intercept. Okay, that's a clue. And it's the same slope. So what does that mean? That means it's the same line. There we go. Next question. Last one. Oh, they love this standard form. Okay, they've been hammering it home. So we need to subtract 4x from both sides. Subtract 4x to both sides. We get 2y equals, I'm going to write 10 minus 4x this time, just to show you that it doesn't really matter. Divide by 2, divide by 2. I get y equals 5 minus, and then that's 2x. Okay? Pretty sure that did that right, yeah. Then we got this guy, okay. Maybe it looks the same, maybe it's different. Let's see what happens, minus 4x, minus 4x. Okay, now we have negative 2y, so it's going to be a little different, equals, again, I'm going to keep the x first this time, and then minus 10. Okay. I need to divide by negative 2 now to both sides. So I get y equals negative 4 divided by negative 2 is positive 2x. And then we have negative 10 divided by negative 2 is a positive 5. Okay, so this is like a trap question. It's a trap question because the slopes are different, okay? We have negative 2 and we have positive 2. So the slopes are different, but they're not reciprocals. And so they're not parallel lines. It can't be the same line. So already we know that it's going to be intersecting but not parallel lines. The trap is they give you the same y-intercept. So they're trying to like trick you into being, oh, is it the same line? Oh, does that mean they're parallel? No. Okay, the y-intercept is not relevant unless it's the same line. So, but it needs the same slope. In this case, they're different. So they're intersecting, but they're not perpendicular. And that's all there is. I hope you guys enjoyed this video. Thank you so much for watching, and I'll see you next time on Wes Explains.